And so first let me introduce myself and Ákos, and probably a lot of you know both of us. My name is Katalin Borszéki and I work in implementation, and I also have here Ákos Rektoris, who is our Open BIM guru, and he's going to be here. Well, first of all, we prepared this webinar together. He was, of course, the main person responsible for all the content of it, and he's also going to be here to answer questions for you. So we would like to ask you this time to wait with all your questions till the very end of the webinar. First of all, because it's sort of dense and there's a lot of little details going on, and we don't want to take away time with asking questions. But second is that we are going to sort of select from your questions and reply to those that seem to be the most important for everyone or the most relevant. And then if there are a lot of questions, we are going to get back to you. So hold on, and we will get back to you if your specific question doesn't get answered after the webinar. We are demoing this topic in ARCHICAD 19, so a couple of the features are ARCHICAD 19 features, but it also covers generic workflow of Open BIM. So most of the workflow steps are true for 18, for 17 as well. But the demo is going on in ARCHICAD 19, so just be aware of that. So probably we all know the main message of Open BIM, and the main message is collaboration between design disciplines using open source, meaning available for all software developers, model and data exchange formats. These formats are well known, IFC and BCF. However, maybe not all of us know what hidden opportunities lie in the Open BIM-based workflows and what tools ARCHICAD offers us along this workflow. So we have sat down and prepared this training to show how easy and clear the basic concepts of the Open BIM tools are, including IFC and BCF, and how useful it is to make it part of our workflow, even if we are not required as per se to generate IFC files at the end of a project cycle. So our project, we are presenting this demo on a real project, Rift Architects Residential Complex in Norway, in the heart of the Oslo Fjord. And the project includes over 1,000 apartments, a hotel, kindergarten, several restaurants and shops, offices. ARCHICAD and Tekla structures was originally used to create the project, but for the purpose of this demo, we have added some MEP elements designed by DDS-CAD MEP into it, although those will come in the second part, so you won't see those today. Now, the concept of collaboration is of crucial importance, of course, when we are talking about Open BIM. And for all team members to be on the same page, we need a shared system. And this shared system has to include identical project location settings, so an identical project origin, north direction, and story system. And we also need proper element classification, structural function classification, and position classification. Of all these concepts, to use a shared project location setting is probably known by most users, so we will skip that and we will jump right into talking about element classification first. As you can see on this image, each ARCHICAD element type has a matching default IFC type. So for example, a column is matched as an IFC column, and etc. IFC-based coordination is about sharing three-dimensional elements primarily, but there is a simple possibility to share some two-dimensional elements as well. 2D elements become line and text type annotation elements. And for example, dynamic dimensions become the combination of static text and lines. Now, most of the default IFC types are self-explanatory. However, as you can see here, GDL objects are an odd one out in this type of matching, since their IFC types are decided based on their subtype. So for example, on the next slide, we have an armchair object, and its subtype is seating here, and there is no seating type matching in an IFC scheme. However, there is a furnishing IFC type. So in such a case, the program searches for a suitable subtype by moving upwards in the subtype tree hierarchy. So in this example, furnishing is the proper so-called parent subtype, which you can see here, or parent supertype. So this armchair is set as an IFC furnishing element by default. If there is nothing, if there is no matching element under the model element supertype that matches an IFC category, the object will be set as a relatively damp solid called building element proxy in the IFC scheme. So let's look at another example. Let's see one building of the demo project, and we will look at the slab here. And let's go to its setting. And I'm going to check the element classification here. The element classification value in the tags and categories panel is ARCHICAD type, which means that the default ARCHICAD IFC type mapping rule is used. A lot of the users don't really understand this, so I'm going to repeat it. It's the default ARCHICAD IFC type. This element defined by the slab tool is automatically matched to a slab in the IFC scheme. So if you look at it lower here, it's called an IFC slab. Let me add as a note on the ARCHICAD type element classification that for now, till ARCHICAD 20, using this automatic classification is a good idea, because this default classification understands the objects and should only be changed if there is a specific reason. So for example, in our next, just in a minute, I will show you how you could specify this slab as a ceiling, and in that case you are advised to change the default ARCHICAD type match. In the future, however, this ARCHICAD type classification might disappear since users do not always understand it. So if we want to model a ceiling element with the slab tool, I will modify its element classification to ceiling, and then as you can see here, the IFC type jumped to IFC covering with the ceiling predefined type attributes. So these defaults are coded into ARCHICAD, and if we set the element classification back to slab, we get the same IFC slab type as the default ARCHICAD type was that we previously automatically had assigned to this element. Staying with the same example, further classification may be set here in this setting window. At the structural function, we may set the slab as a load-bearing element or not, here. And the general practice is that it's defined, the structural function is defined by the structural engineer, but the architect can decide for most elements as well, since it makes the collaboration easier. For example, the ceiling panels and the furniture do not have to go out to the structural engineer in the IFC file, so our project elements could be filtered for load-bearing ones only. They could also be listable based on that, and we can search for them based on that category as well. And as I used the case to send it to a structural engineer, we can leave the irrelevant non-load-bearing elements out of the file that we would like to share with our structural engineer consultant. So although structural function is an ARCHICAD property of elements, it strongly influences the IFC, or it can strongly influence the IFC export as well. Now, in the same window, position can also be set here as exterior, interior, or undefined. Now let's look at another example of classification. This table was modeled as a slab and 4 columns. So see, this is a slab and the legs were columns. And then later on, we converted it to a morph. However, we can easily take this morph. This one on the right is already converted to a morph. and I can go and change the default element classification. That is, as you can see, for morph building element proxy. The ARCHICAD type, the default matching is building element proxy, and I can change that to a furniture. And then once that's changed, the IFC types becomes IFC furnishing element. And then once we have this classification in another view, I can easily search for furniture classified morph elements, for example, with the Find and Select tool. We have set these pre-done search criteria here. So see, I am looking for morph elements that are classified as furniture, and then right away I can select all those elements in my model. Now going on the same line of thought, based on the previously shown position classification settings, we can also select the exterior elements. I have set up another Find and Select search criteria window for it. So now I am only looking for exterior elements, and I can go ahead and show only the exterior elements in 3D. Oh, sorry, show selection in 3D. In which case, of course, I could take this and send only this info out. I'm going back to show all. And of course, again, position classification. I could do the opposite and select all the interior elements of the project. And again, this could go out in an IFC file based on visibility. How about selecting all the load-bearing elements, which is selecting the elements based on structural function. These are all the classification settings that we have looked at in the settings window. Now I am only showing load-bearing parts of the project. Okay. And now we are going to have a closer view. This load-bearing slab has a composite structure, as we can see up here. And I'm going to go and look at this composite. The composite structures dialog shows that there is a load-bearing concrete skin to this composite, this one. So this skin is a core skin. Further filtering for the load-bearing core structure is also possible with the partial structure display settings. So choosing, if I go to the partial structure display settings, which is under document, partial structure display, and then choosing the core of load-bearing elements only, will hide the non-core, meaning the finish and other skins of the load-bearing composite element, and the non-core parts of the complex profile load-bearing element. Modifying the display option shows only the core concrete skin of this specific slab, for example. So another example of filtering for the classification set in the settings, as we have seen. We have taken this model with the classifications we have just shown you and exported it to IFC, so we can go and check the same IFC content of the model in an IFC viewer or checker. In this demo, we are using the Solibri model viewer, for example. So I am going to go to Solibri. And Solibri shows the morph elements that we have classified as furniture. And if you look at it here on the left, it's classified as real furniture element. And if I click on the slab, the slab's position here, external, and structural function classifications are shown as standard IFC properties. So our classification that we have set in the settings for this slab came through to the Solibri viewer in the IFC file. The true value of IS external represents the external position, and the true value of load bearing represents the load bearing structural function status of the element. We are going back to ARCHICAD. And we will talk about property management first. So this was classification till now, and we are on to property management.